Here we're going to look at two applications of the law of sines and cosines. So we'll start with our first example. I'm going to recopy a figure that's in the book. It's figure 1 on page 762. And essentially you've got an airplane. Okay, here's the airplane. It's actually flying, well, it doesn't matter where it's flying. And it's spotted by two radars. One radar is here. And the other one's over there. And those two radars, they are 20 kilometers apart. Now, the angle of elevation of the first radar is 15 degrees. And the angle of elevation of the second radar is 35 degrees. And with this information, we'd like to recover the altitude of the airplane, how high it is. Okay. So what is the altitude of the aircraft? So how do we do this? So obviously there's a big triangle like in the background here, right? There's a triangle with, this is an angle of 35, 15. I know this side here. And what I don't have is, and what I'm trying to look for is the height. Now the height is the height of also this right triangle with an angle here of 15 degrees. Okay, and I don't know any of the other sides of the triangle, but let's call this side maybe A. Okay, so the sine of 15 degrees would actually be the opposite side over A. So that means that the height is A sine of 15 degrees. So if I'm able to find what A is, I'm going to be able to find what the height is. And to find what A is, I can use the law of sines. Because why law of sines? Because I don't know what A is, but I know its opposite angle. I know this side and also know this opposite angle. Well, I haven't calculated it yet, but this is easy to get, right? This is 180 minus 15 minus 35 degrees. So that gives me 130 degrees right there. So I'm able to use the law of sines to get what A is. So sine of 35 degrees over A is in the same ratio as the sine of 130 degrees over 20. And then I can find what A is. So A is sine of 35 degrees over the sine of 130 degrees times 20. And if I calculate this, I get 14.98 kilometers. So I know actually that the first radar is 14.98 kilometers away from the airplane. And then the height is just A sine of 15 degrees. So this is 14.98 times the sine of 15 degrees, and that's approximately 3.88 kilometers. So this is how high the airplane is. Let's take a look at a second example. This time we've got the shore here, okay, and there's a port, okay. So yeah, this is water here. Okay, so we've got water, and this is the land, and here you've got a port. And then you've got a boat that leaves the port and travels 10 kilometers. at some point, the boat turns west by 20 degrees and travels another 8 kilometers. And then what we want to find is how far the boat is from the port. So we can call that D for distance. Okay, what is D? So obviously here, once again, there's a triangle that we need to look at. This triangle here. What's the angle here? Well, it's the supplementary angle. This is 180 degrees minus 20 degrees, so that's 160 degrees. We know this side, 10, we know 8. So this is a perfect setup for the law of cosines because we have the two adjacent sides to the angle. That we know. So in other words, D, that we don't know, so D squared is 8 squared plus 10 squared minus twice 8 times 10. So essentially I'm applying a squared equals b squared plus c squared minus 2bc cos theta. So cos of 160 degrees. And therefore, if you calculate this, d squared is approximately 315.35. And taking the square root, d is simply equal to 17.73 kilometers. Maybe a small note that I on the so note on the cosine law, on the law of cosines. So a squared we said is b squared plus c squared minus 2bc cos theta. Okay, where you know, this could be theta, this could be b, c, and a is the opposite. What's important is that a is the opposite side of theta. Okay, what if theta is 90 degrees? What is this law in that case? What if, so in other words, what if I've got a right triangle? What if the angle is right? So A turns out to be the hypotenuse of the triangle, and B and C are the two legs of the triangle. So what happens then? We get that A squared is equal to B squared plus C squared minus 2BC cos of 90 degrees. But what's cos of 90 degrees? That's 0. So in other words, this entire term is 0. And essentially we've got that a squared is b squared plus c squared. And we've got the Pythagorean theorem. Which is not a big surprise because we actually use the Pythagorean theorem to derive the law of cosines. So in other words, when theta is 90 degrees, the law of cosines is a special case of... the Pythagorean theorem is a special case of the law of cosines. So you can think of the law of cosines as, it's kind of like a generalized Pythagorean theorem version. Generalized version of the Pythagorean theorem. Maybe that's better. Version of the Pythagorean theorem.